Hello everybody, we're going to code something interesting today. We're going to code a flickering screen, just like a TV screen, in SDL. And this is the first time I'm ever using SDL, but I've played around with it and we can manage to do it. So right now I'm in an empty directory and I'll create a file, let's call it tv.c, and include the libraries, include SDL2 and this one right here, and then of course also include standard library.h. The first thing that we will implement is a simple window that will open in SDL. So you can think of this video like a hello world video, but with an interesting twist. So if you have never used SDL, then this is the video for you. You will get some basic insight from someone who has used SDL for a couple of hours before. So yeah, great experience. Okay, the first thing you need to do is to call the SDL init function. And this is a function that initializes, well, SDL components, and you can initialize, well, the keyboard, joysticks, audio, and video. And in this case, we're only interested in displaying stuff, so we're going to pass a bit flag here that is the SDL init video. Normally, this function returns values, whether the initialization was successful or not, but I'm not going to do any error handling in this video. I'm just going to keep it completely simple so that, well, in a way that I can keep an overview here. I don't want to clutter this too much. Okay, so after initializing something, we can already create a window, and it works like this. We call SDL window, get a handle of that, and use the following function SDL create window, this one right here. Now we give that a title. I'll call it TV, or my broken TV. You will see why later. And then we can give that coordinates where to initialize the window. I'm going to use some library coordinates, window position centered, and here as well, window pos centered. And then we can give the window a size. It does not really matter which size. Let's give it 600. Let's do, what would be a good size? 900 by whatever. It does not matter. I always waste time on this unimportant stuff. Oh, and the last item is this 0. What was that 0 again? Wait. 1 second. What was that 0? We just checked this SDL create window. I've done all of that, almost all of that, using these using this documentation here. So we did SDL create window. The last flag is a UN32 flags 0 or one or more SDL window flags. Okay, we don't need that. That's why we used a 0. Okay, now we have a window created, and I think at this point, well, will the window show? It might show if we introduce a delay. It might show for a millisecond and then disappear already. So let's do a 5 seconds delay. Okay. Save that and compile. Wait, I'll enter a tmux session for convenience. let's do cc tv.c, and the output name is supposed to be TV, and then we're going to provide SDL, well, compilation flags. I have this statement here from the documentation. I can show you what that means. Why is it not compiling? Typo, tv.c. Okay, so if we type this on its own, then it will evaluate to these flags for the C compiler. I have this from the introduction from the official documentation, so I just use it. If we don't use it, then the compilation will break. So we use it. Okay, let's execute TV, and what happens? We already have a window, so that is quite nice, I think. Does it move? Yes, it moves. Okay. So, and it has the title, My Broken TV. Again, My Broken TV, and the specified size. So that is already quite nice, I think, considering that we're using C, which is extremely low level for, well, what I'm used to. So let's continue our journey. So we have a main function opening a window, and then we're waiting. Now I would like to get something onto that window, something drawn, and to do that I would like to, well, show you something first. When we create a window, we get a window handle, and from that window handle we can call another function that is called getWindowSurface. So let me look that up. Where is it? getWindowSurface, this one right here. And this will return a handle on an SDL. No, that is not it. getWindowSurface. Oh, we are on SDL3 documentation. I'm using SDL2, so that is a difference right there. getWindowSurface. So this should be it. Right, and we're getting a return handle on an SDL surface object right here. And this is the syntax or the type definition of the SDL surface structure. And as you can see, well, we get the surface of the window returned, and the surface contains several fields. One is or two are the width and the height of the surface of the displayed window. Then the pitch is, what was it? It was documented somewhere. The pitch was I don't recall it. It was not as important. Then we get a pointer to the pixel data. Okay, so that's where we write into. That's the actual binary data that resembles the pixels. And then very important is this so-called SDL pixel format right here. This is the format, well, this format specifies the size that your pixel have. For example, if you're compiling to a very small computer, for example, a handheld video game, whatever, an old-fashioned thing, then the display might have only 8-bit pixels. Modern computers usually have 32-bit pixels, but this format here specifies the size of the pixels. And there should be a documentation for that here as well somewhere. Where is it? There's so much stuff. Yeah, here's the pixel format. And as you can see, there's a bunch of graphics related or color related stuff in here. What's important for us is the bytes per pixel. So how many bytes is one pixel? And I guess that's what I want to show you right now. And so let's continue and draw something to this screen. So first, as we just checked, we have to get the SDL surface and get a handle on that window. Okay, the surface. And then we need to retrieve that from this library method right here. Git get window surface and retrieve that from the window. Okay. Now the next thing is, then as the next step, we can actually already draw bytes to the surface using this pointer that we checked here. Yeah. And how do we do that? We create a new method. Do we create a new method now? I think we should create a new method, and I will call it print random data. And we will pass the surface into it. Let's define that method. Print random data, and it accepts an SDL surface. And now we can, from that surface, get the surface format, the pixel format, and retrieve, first of all, the, wait, where was it? The pixel format. Here, int, I will create a new integer, bytes per pixel, and we can call the surface, then the format on that surface, that should be it. Yeah, surface, format, and then call the pixels, and that retrieves the bytes per pixel. So let me just print that to bytes per pixel. Print that to the console just so I know how many bytes per pixel I'm getting. Bytes per pixel. And I need to include standard IO. Okay, let's compile. That does not work. Why does it not work? Because that arrow operator does not return something that we accept. Why? We return a, yeah, that's completely wrong. We need the bytes per pixel, because we are accessing the format, not object, the format structure, which is this right here. And then somewhere here, we are accessing the bytes per pixel. Okay. Let's try to compile that. And when we execute the TV, we still get the black screen and the printout that we have 4 bytes per pixel, and that is the usual pixel size today. So either we can hard code that, or we can still handle the other sizes. I would prefer to hard code it for today. We could do a switch case statement where we handle what do we print for pixels of 1 byte size, for pixels of 2 bytes, etc. But let's just handle the 4 byte size that suits my screen and most of your screens as well. So let's first get the total number of pixels that we want to draw, and that can be found as follows. It's quite simple. We get the surface and then the width, and we multiply that by surface and get the height. What is my compiler saying here? Unused variable. Okay, that's not something bad. I mean my linter. And then we will get a, what do we get next? We have to draw to surface. Do we draw to surface? I can never remember here these data types here. Surface pixels. We can directly draw to surface pixels. Surface pixels. This is the access to the object. And because it's a void pointer, we need to cast it to something. And it's a good idea in general to do a 1 byte, well, pixel size, or not pixel size, but data size. So that we can, well, write bytes into that. But it doesn't really matter, actually. Then call that pixels and cast uint8 pointer. And that should work. Is it not compiling? Unknown type, then unit uint8 unsigned integer 8. And then let's draw something. We by looping over the pixels for int I equals 0, I smaller than number of pixel, I plus plus, and here we can draw. What can we draw here? We can draw a random integer that would be a 32-byte return value into that uint32. Wait, because my screen is 4 bytes per pixel, I should be able to just say that pixels are 32 bytes. uint32. Okay, so I'm getting a random integer, and a random unsigned integer here, and I'm writing that into the pixels. And we can do it like as follows. So we, oh no, bullshit, no. We just say pixels at I should be this random number. I think that should be it. Okay, let's try to compile that. I think we are now drawing something to the screen. We're not. Why are we not? Okay, I need to compile, obviously. Come on. So I compiled. And it's still a black screen. Why is it still a black screen? We are printing random data to the surface here. Okay, yeah. Of course, I forgot something. We're printing random data to the surface, but then we have to tell SDL to update the window surface and actually draw and update the pixel data. I hope that's it then. We have to say SDL update window surface and then provide the window. Because that window already should have a handle to the surface, and by saying update window surface, we are updating what is being displayed. So let's just try that and execute the TV. And as you can see, we get a broken TV right here. but I would like to see it flickering. And that's the interesting part, I think. So far I'm quite happy. So we have a printout of random numbers to the pixels array. Okay, it's quite simple, I admit it. But let's just animate that, because moving things are always more interesting to look at than, well, static images. And to do that, we do the following. We create a loop. Let's just do it incredibly stupidly, like this. I'll just put it into a while true loop, basically. Come on. I need to polish my Vim skills or my attention to the keystrokes. So what did we do? I did not moderate that enough. So I created a while loop that loops over the printout of random data. It updates the Windows surface, and then the delay between the individual images should be, let's say, 100 milliseconds. And let's print that. Let's compile that first and then execute it. And as you can see, we get a flickering screen, and it's quite beautiful, I think. So if you think that's beautiful, then please leave a like. And now the unfortunate thing is that, well, we created a while true loop, and it does not interrupt regardless of what I do. So we have to do I hope you can see that now. Let me just create a new pane down here so you can see it better. I have to print out the processes and do a kill -9 because otherwise this won't interrupt. And we have to implement a proper interruption. So now this is done. And now the process has interrupted, but this is really not something that we want. And to do that, we can listen for so-called SDL events. And these SDL events could be, well, keystrokes, events on the window, mouse clicks, you name it. And to do that in the while loop, we can just ask SDL for an event, SDL poll event, and provide an address to an event. That event will be defined up here, SDL event, like this. So we're polling an event. SDL is writing something into that structure. And if the event.type is SDL quit, so if we quit the window, then we will set a Boolean flag running equals 0. So this is false. And here I'm going to introduce that flag. Running is 1. And here we change the while loop to consider the running variable. So we're checking running is true, running is 1. While running is 1, we're drawing new images to the SDL window. And when SDL senses a new event that was fired, we're setting running to 0, and then we're quitting the execution. So let's try that and compile. I need to make the screen larger a bit. And now we got a beautiful broken TV simulator. And if everything worked out, then we can exit it like this. And this was it. This was my small introduction to SDL. I have no clue myself. I was experimenting with it myself today. And yeah, I find it quite cool. I would like to sometimes these escapes do not work. Well, there must be some detail that I'm not aware of yet. But anyways, I would like to decrease the delay a bit to make it look even better. Let's make it 5 milliseconds and have another look. Yeah, and that really looks like a broken TV. I hope you can see it in the video on YouTube later, because this is really random data, pixel-wise random data. I'm not sure how that looks in a compressed and uploaded video, but this looks really trippy now. So this is really, really nice. And I think I spent my evening well with this today. And I hope you enjoyed it. If you like that video, then please leave a like and subscribe. And leave your comments down below. What else can we do with SDL? What else can we do with whatever you're interested in? I'm happy with that. And let me know what you think. Bye.